Hello, everyone. Welcome to Chapter 5. We're working with the Cengage Managerial Accounting textbook. And this week we're going to talk about how we go about allocating support departments. Well, if I can get it working here. There we go. Okay, so for this chapter, we're going to talk about allocations of these support departments. What a support department really is a service that's necessary that helps produce products, but really isn't part of the production process. Sometimes they can be called service departments because they can provide services to other departments, kind of like a printing department. All of the direct costs of the support department get accumulated in the center, and then some general factory overhead, like depreciation, is assigned to a support department. Because these departments are just indirectly related to the production, it's hard to apply these to products. So we're going to talk this week about how we allocate those costs into the product costing system. Since they're indirectly related to production, they're applied to the products as part of overhead. As we're going to see, overhead can be applied to products using several different methods. Here we show we can apply the overhead using what we call a single plant-wide rate. We can use one based on multiple production department rates. And we can also use activity-based costing. When we use a single plant-wide overhead rate, we use that to apply overhead to products, and the support department costs are just combined with all the other overhead costs. When there's a single driver used, it's not real likely that the driver selected is really appropriate for every type of overhead. And using the single plant-wide rate ignores the fact that the processes used in manufacturing a product might be different from those used possibly for other products. So some processes require more support activities than others would. And so really, they should be allocated by more support department costs. Using the single plant-wide rate can have inaccurate product cost results. So here, when we have overhead costs and we utilize a single plant-wide rate, the overhead costs are used for everything, for all the products. When we use a multiple production department rate, then we apply overhead to products, and the overhead costs are directly traced or distributed to support and to production departments. Support department costs then get allocated to various production departments based on the amount of support activities that's used by those production departments. After support department costs are allocated to the production departments, then those costs are applied to the the products using various cost drivers from each of the production departments. So as you see here, there are various overhead costs. And you can see that you'll find where we can trace and distribute those costs to the departments that use those overhead costs. So the support departments, there may be several, and then we need to allocate those support department costs to the various production departments so we can make sure the costs are added into the final products. When we use activity-based costing to apply overhead to products, we call those support department costs support activity costs. Those overhead costs are directly traced or distributed to support and production activities, and then the support activity costs are allocated to the various production activities based on the amount of activity used by each of the production departments. Finally, production activity costs are applied to the products using cost drivers for each production activity. So when we transfer overhead costs to the support and production departments, we refer it as to distributing overhead costs. Transferring costs to products is referred to as applying costs to products or application of costs. And then transferring costs among departments is referred to as cost allocation, or what we just call allocating costs. Here we see how we handle it when we use the activity-based costing. We, again, trace and distribute the overhead costs to the support production activities. And ultimately, these costs do get added to the products. So if we look at this first exercise, under activity-based costing, transferring costs among departments is known as cost allocation. So now we're going to look at how we go about allocating these support department costs to the production departments. 3 methods that are used. One is the direct method, one is the sequential method, and one is called the reciprocal services method. The direct method's the easiest, but not as accurate. The sequential method's more difficult, but produces more accurate allocations. Now, the reciprocal method is the most difficult, but does produce the most accurate allocations. All of the 3 methods require this 5-step process, where we directly trace and distribute overhead costs to support and production departments. We find a cost driver. We determine the usage of the support department cost driver by each department, and then we determine the percentage usage of support department cost drivers by each of the departments, and then we allocate support department costs by multiplying the support department costs by the percentage usage. So once steps 1, 2, 3, 4, and 5 are complete, costs get applied to the products. Now, in previous chapters, we've talked about the application of costs from production departments to products. This chapter is primarily going to focus on steps 1 through 5. The direct method is what we're going to talk about first. The easiest, but not as accurate. It allocates all support department costs directly to the production departments. It ignores the possibility that some support departments may also serve other support departments. The sequential and reciprocal methods do consider inter-support department service costs. Let's assume Decker Tables has 2 support departments. They have a janitorial and a cafeteria. They have 2 production departments, cutting and assembly. In step 1, the following costs have been directly traced and distributed to each of Decker Tables' 4 departments. Under the direct method, any inner support department usages are ignored. So, for example, the fact that the janitorial department has 10 employees that use the cafeteria doesn't get considered. Also, the fact that the janitorial department cleans 5,000 square feet of the cafeteria department is not considered either. The denominators in the computations here are 5,000, 1,000 square feet for the cutting, 4,000 square feet for the assembly. For janitorial costs, and 30 employees in one department, 10 in the other department for cafeteria costs, which are the total of the cost driver usages for the production department. So, as you see here in step 5, the support department costs are allocated to the production departments by multiplying the percentage usage of only the production departments by the total support department costs. So as you see, the janitorial costs of $310,000 are allocated $62,000 to the cutting department and $248,000 to the assembly department. The cafeteria costs of $169,000 are allocated $126,750 to the cutting department and $42,250 to the assembly department. The support department costs are added to any costs that were directly traced or distributed to the production departments in step 1. So the total cost of the cutting and assembly departments, you see the cutting departments, $1,504,000 from step 1, $62,000 from step 5, and then $126,750 from step 5. Same with assembly. So as we see in this exhibit 6, after the support department costs have been allocated, the support departments don't have any costs remaining. And since all costs have been allocated to the production departments, management can apply those costs to the products. So as you see here, we are now 0 costs for janitorial and cafeteria, and they've been applied directly to the production departments. Now, the sequential method, sometimes it's called the step-down method, considers some inner support department services. The costs are allocated from one support department to the other and to the production departments. Then a second support department is selected and its costs are allocated to the remaining support departments, but not to the first service department, and then to the production departments. And we continue this process until all the support departments have been allocated to the production department. Using this method, support department costs never get allocated back to a support department whose costs have already been allocated. So while it captures some of interdepartment services, it doesn't capture all of them. So the preceding factors may conflict. So, for example, the support department with the highest cost may serve the fewest number of other support departments. As a result, managers often make subjective assessments about the order of allocating support departments. Note that usage of the cafeteria department by the janitorial department isn't considered. This is because the cafeteria department costs are allocated after the janitorial department, once a support department's costs are allocated under the sequential method, it's not allocated any additional costs. Here, the total support department cost to be allocated will also include any costs that were allocated to that support department from other support departments. Here you see with the janitorial costs of $310,000, they get allocated to the cafeteria, cutting, and assembly departments, and they do that by taking the total costs by each of the departments' percentage. But the total cafeteria department costs of $324,000 are allocated to the cutting and assembly departments, shown here based on the applicable percentage of employees. As you see on this slide, after the support department costs have been allocated, the support departments have no costs remaining. So since all costs have been allocated to the production departments, now management can apply the production department cost to products. The total costs allocated to the cutting and assembly departments are different depending on which support department allocation methods used. You see here the difference between the direct and the sequential. The reciprocal method yields the most accurate allocations of $1,758,200 for the cutting department and $904,800 for the assembly department. The direct methods is a little lower for the cutting department, but higher for the assembly department, since they don't consider that inner support department services. The sequential methods allocations are more accurate, but they're more difficult to compute. So let's take a look at this question. Which of the three methods used to allocate support department costs to production departments is considered the most accurate? Is it the reciprocal service method? Yes. And we will look at that soon. Okay, so as we look here at this exercise, we're going to go through several exercises actually here, so we can really understand these methods. This is exercise 5.1. Yotown produces yogurt. Information related to the company's yogurt production follows. Support Department 1's total costs of $157,000. Using the direct method of support department cost allocation, determine the costs from support department 1 that should be allocated to each of the production departments. So if you look, we're going to take the cost driver, $1,500 for department 1, $200 for department 2, $300 for department 3. All of it is $2,000. $1,500 of $2,000 is going to be 75% of the support costs will go to department 1. 10%, 200 divided by 2,000, that's how we come up with the ratio, will go, 10% of the support costs will go to department 2, and 15% of those costs will go to department 3. So pretty straightforward. Here we're looking at the sequential method. Black Diamond Devices produces replacement components for smartphones. Costs from support department 1 are allocated based on the number of employees. Costs from Support Department 2 are allocated based on asset value. Relevant department information is shown here. So we know exactly how many employees are in the 2 support departments, 2 production departments. We have the asset value and the department costs. Using the sequential method of support department cost allocation, determine the total cost from support department 1, assuming they're allocated first. That should be allocated to support department 2 and then to the production departments. So here, the support department 2, when we look at employees, we see that support department 2 has 10 employees, production department 1 has 15, and production department 2 has 25. So 50 employees we're allocating among. And if support department 2 has 10 employees, that's 20% will be allocated to the support department 2. So you see the support department 2, 20% of support department 1's $35,000 of costs will be allocated to department 2. And then 30% of the costs from support department 1 will be allocated to the production department 1. And 50% of the support department 1 costs will be allocated to the production department 2. Here's another one. Christmas timber produces Christmas trees. The trees are produced through a cutting and pruning process. Machine maintenance and janitorial labors are performed throughout the production process by non-production employees. Maintenance and janitorial costs are allocated based on machine hours used and the number of trees in each department, respectively. So the company estimates that the cutting and pruning areas typically have 20 and 60 trees, respectively, in them at one time. The company also estimates that the cutting process requires about 9 times as many machine hours as does the pruning process. The total cost of each department are shown here. Using the direct method, determine the total cost of each production department after allocating all of the support costs to the production departments. So we're going to look at the maintenance and the janitorial support departments and see how we go about applying them. So the maintenance department, we are going to allocate 90% to the cutting department and 10% to the pruning department. And so the $7,800 will be applied in that fashion. So let me just see here. 20 and 60 trees. So the cutting department usually has about 20 trees, and the pruning department has 60 trees. But since the machine hours, you see in the cutting department, it requires 9 times as many machine hours as the pruning department. So that's how we are estimating the hours. If we have a total of 10 hours and the cutting department requires 9 of those 10 hours, we're allocating 90% to the cutting department. Okay, so then as we move on to the janitorial department, we're going to do that based on the number of trees. So you see with the cutting department, since they are usually sitting with 20 trees at a time, and the pruning department sitting at 60, we'll take 20 divided by 80, or 25% of the cost of the janitorial will flow into the cutting, and 75% of the janitorial costs will then flow into the pruning department. So after that, the cutting department will have its costs of the maintenance department of $7,020, of the janitorial department of $1,250, plus its own costs of $54,500, for total cost now of $62,770. The pruning department will have maintenance costs of $780, janitorial cost of $37.50, and its own cost of $11,000 to come up with a total of $15,530. Okie doke. Now for exercise 5.4. Marde Creations produces winter scarves. The scarves are produced in the cutting and sewing departments. The maintenance and security departments support these production departments and allocate costs based on machine hours and square feet, respectively. Information about each department is provided in the following table. Using the sequential method and allocating the support department with the highest cost first, allocate all support department cost to the production departments, then compute a total cost. So we know that the security department is $4,500 of cost. The maintenance department is $2,200 in cost. So we'll allocate the security department costs first since it's higher. When we talk about how we're going to go about allocating it, it's going to be based on square footage. So you see the maintenance department has 600 square feet, the cutting department has 2,400 square feet, and the sewing department has 3,000 square feet. So a total of 6,000 square feet. So since the total square footage is 6,000 square feet and the maintenance department has 600, that's 10% of the total square footage. So the maintenance department will take, or the allocation will be 10% of the security costs. The cutting department will be 40% of the security cost, and the sewing department is 50% of the security cost. Now we've got, for the maintenance department, $2,200 their cost, but the allocation from security is $450. So we need to allocate $2,650 of maintenance support to the other two production departments, the cutting and the sewing. And this is now based on machine hours. So the cutting department, the 3,600 machine hours divided by 9,000 machine hours would be 40% of the maintenance department cost, and the sewing department would receive 60% or allocate 60% of those costs. So you see now the cutting department will have its $21,200 cost, along with $1,600 from the security department and $1,060 from the maintenance department. The sewing department will have its $24,900 in costs, and then $2,250 from the security department and $1,590 from the maintenance department. Boy, sometimes I don't know why this won't move. There it goes. The direct method again, for this exercise, we've got Becker Tabletops, has 2 support departments and 2 production departments. If we allocate using the direct method, we will just take those departments and allocate them totally to the production departments. Janitorial being square footage, cafeteria department being number of employees. So the janitorial department being square footage, the cutting department is 1,000 square feet. The assembly department has 4,000 square feet. So the janitorial cost for the cutting department is 20%. For the assembly department is 80%. Cafeteria is based on number of employees. If the cutting department has 30 employees and the assembly department has 10 employees, 75% of the cafeteria department will go to the cutting department, and 25% of cafeteria will go to the assembly department. Looking at joint costs, because joint costs are by definition inseparable, managers must be careful when analyzing and interpreting product costs that include joint costs. Methods for allocating joint costs are going to be looked at next. As you see, because each of these methods allocate costs that are technically inseparable, none of the methods are going to be consistently allocating joint costs more accurately than another. But depending on the production process, one method could be more appropriate than another. So here, the physical units method allocates cost using a physical measure of the products at the split-off point, be it pounds, gallons, or inches. Assume that Davis Pharmaceutical manufactures 3 luxury beauty products: a skincare cream, a shampoo, and a liquid hand soap. The cream, the shampoo, and the soap go through a joint production process where mud from the Dead Sea in Israel is refined and combined with other chemicals to form the basis of all 3 of these products. So you see here, the joint costs show the direct materials, the direct labor, and the overhead. Assume that at the split-off point, the following quantities of products exist. So we've got the skin cream of 200 pounds, the shampoo of 150 pounds, and the soap of 150 pounds. In this case, we will look at the allocation. So if the skin cream, 200 pounds divided by the 500 pounds, 40% of the joint cost are going to be allocated to the skin cream. For the shampoo, we'll take 30% of those costs to allocate them to the shampoo, 150 divided by 500 pounds. And the soap will be the same. So at that split off point, based on weight, that's how we're going to allocate the costs. The weighted average method allocates joint costs based on weight factors for each product. The weight factors are multiplied by physical units to arrive at the weighted physical units, and then used to allocate the costs. Okay, let's assume here that we allocate for Davis Pharmaceuticals the mixing speed required in the joint process for shampoo is 3 times that of cream and soap. So management applies a weighting factor of 3 to shampoo and a weighting factor of 1 to skin cream and 1 to soap. So in this scenario, we'll take the 450 pounds, 150 pounds for shampoo times 3. And then for skin cream, we'll take the 200 pounds times 1. And for the soap, we'll take 150 times 1. In this case, we then have a mixing weight factor along with the quantity. And so you see here, the weighted pounds are now 800 pounds. So if the skin cream has 200 pounds of the 800 pounds, that's 25% of the mixing time. For shampoo, since it's a 3 times factor, they're going to have 56.25% now of the weighted percent of the mixing time, and the soap will be 18.75. So taking this weighted average is the method of how we went through this process here. Then we can do another method, the market value at split off. For this method, we allocate joint costs using each product's total market value at the split off point. Products that have a higher market value get allocated more joint cost. When we use this, we have to estimate the market value. And if a product is sold at the split off point, its actual sales price is going to be used. Because most products are processed further after the split off point, this is kind of hard to always estimate market value. But let's just assume here Davis sells the skincare cream and shampoo at the split off. Soap has to be processed further. If the skincare cream sells for $540 a pound and the shampoo sells for $480 per pound, we then will allocate those based on what we know the selling price is. Although the soap requires additional processing, management comes up with an estimate of soap being at $400 per pound at the split off point. So we can allocate the number of pounds times our estimated selling price to come up with our total market value at split off. When we do this, we see the total market value at split off is $240,000. We would take the portion of the skin cream of $108,000 of the $240,000, and 45% will be allocated to the skin cream. The 30%, the $72,000 divided by $240,000, that 30% will be allocated to the shampoo and 25% to the soap. Next, we have the net realizable value method. And in using this method, joint cost using each product's estimated net realizable value after it's been fully processed. Net realizable value is the estimated selling price of a product less any cost necessary to further process the product beyond the split off point. For products processed beyond the split off point, we compute the net realizable value by the final selling price times the quantity minus any additional processing costs that have to occur. Products not processed beyond the split off point, the net realizable value is the selling price at split off times the quantity. So here we've got the selling price at split off. We've got additional processing costs, and we've got the selling price as after the additional selling costs. Davis Pharmaceutical has to decide which products to process further and which to sell at split off. We're going to see here the net realizable values from additional processing for skin cream and soap are higher than when selling the products at the split off point. Davis wants to process it further. The net realizable value for shampoo is higher at the split off point without further processing. So that one's not going to be processed any further. You see here the skin cream, there aren't any additional costs. That's the net realizable value. When the skin cream is processed further, then we subtract the additional cost to come up with the net realizable value. Same with shampoo at split off and shampoo processed further, and then the soap processed further. So the soap doesn't, there is no selling price at split off. It has to be processed further. So giving those numbers, the percentage of net realizable value of the three products will be the skin cream. The net realizable value there was $144,000. And the shampoo was $72,000. And also for the soap processed further, that was also $72,000. So our total net realizable value of $288,000, 50% is allocated to the skin cream and 25% will be allocated to shampoo and soap. The joint costs are going to be allocated based on that net realizable value. So the joint cost allocations for skin cream, shampoo, and soap are all different depending on which of the four joint cost allocation methods would be used. A subjective determination has to be made as to the appropriate method to use. If management wants joint cost allocations to reflect the difficulty with which products are made, then the weighted average method would be most appropriate. But if management wants joint cost allocations to reflect the final market value of products, then the net realizable value method would work. In this case, more joint costs would be allocated to the products that are better able to cover those costs. Here, as you see, the comparison between the physical units, the weighted average, the market value at split off, and the net realizable value methods. There are different numbers based on which method is being used. Let's look at some exercises here. So we'll start here with physical units method. Woodfall Inc. produces the following types of 2x4x10 wood boards, washed, stained, and pressure treated. These products are produced jointly until they're cut. One batch produces 100 wash boards, 60 stained boards, and 40 pressure treated boards. The joint production process costs a total lot of $3,500 per batch. Using the physical units method, allocate the joint production cost to each product. So here you'll see we've got the boards per batch, and the washed boards are 50% of the total batch. Stained boards are 60% of the total batch. Pressure treated are 60 of the total batch, which amounts to 30%. And the pressure treated are 40 of 200, which amounts to 20%. So those joint costs will be allocated based on physical units. Here, if we take a look at the weighted average method, custom carvings company jointly produces wood chips and sawdust used in agriculture. The wood chips and sawdust are actually byproducts of the company's core operations, but custom carvings accounts for them just like normally produced goods because of their volumes. One jointly produced batch yields 2,000 cubic yards of wood chips and 6,000 cubic yards of sawdust. The estimated cost per batch is $26,300, but the joint production of each good is not equally weighted. Given management's estimates for how long it takes to make sawdust versus wood chips, a weight factor of 14 is used for wood chips in the joint production process, and a weight factor of 2 is used for sawdust. Based on this information, allocate the joint cost of production using the weighted average method. So you see, if we have 6,000 cubic yards of sawdust at a weight factor of 2, that gives us 12,000 cubic yards of production time. Wood chips, 2,000 cubic yards at a weight factor of 14 gives us a $28,000 weighted cubic yard. So we've got the percentage 12 over 40 or 28,000 over 40 gives us our percentages. So the sawdust will take 30% of the joint costs and the wood chips will take 70% of those joint costs. Here we'll look at market value at split off. Sugar Empire jointly produces raw sugar, granulated sugar, and castor sugar. After the split off point, raw sugar is immediately sold for 24 cents per pound, while granulated and castor sugar are processed further. The market value of the granulated sugar and castor sugar is estimated to be both 25 cents at the split off point. One batch of joint production costs $1,700 and yields 2,500 pounds of raw sugar, 3,600 pounds of granulated sugar, and 2,000 pounds of castor sugar. Allocate the joint costs using the market value at split off. So the granulated and castor is at 25 cents. The raw sugar is at 24 cents. Based on the pounds times the market value, we've got our total market value at split off. Therefore, the raw sugar is going to take 600 divided by 2,000, or 30% of the cost. The granulated 900 divided by 2,000, 45% of the cost. And the castor sugar will take 25% of the cost. Here, net realizable value method. Nature's Garden produces wood chips, wood pulp, and mulch. These products are produced through harvesting trees and sending the logs through a wood chipper machine. One batch of logs produces 20,400 cubic yards of wood chips, 10,400 cubic yards of mulch, and 9,200 cubic yards of wood pulp. The joint production process costs a total of $34,000 per batch. After the split off point, wood chips are immediately sold for $425 per cubic yard, while wood pulp and mulch need to be processed further. The market value of the wood pulp and mulch at the split off points are estimated to be $202 and $425 per cubic yard, respectively. The additional production process of the wood pulp costs $5 per cubic yard, after which it is sold for $30 per cubic yard. The additional production process of the mulch costs $4 per cubic yard, after which it is sold for $27 per cubic yard. Allocate the joint cost of production to each product using the net realizable value method. So we know the market value at split off Then the market price per cubic yard. The wood chips don't need to be processed further, but the wood pulp and mulch does need to be processed further. So therefore, we find the net realizable value per cubic yard at the split off, or I should say the market price subtract any additional costs that need to happen, which then gives us our net realizable value. We take that times the cubic batches to give us our total: 510 for wood chips, 230,000 for wood pulp, and 260,000 for mulch. We come up with our percentages and allocate the joint costs based on those percentages. Here's another weighted average method. Gordon's smoothie stand makes 3 types of smoothies: blueberry lemon, orange swirl, and triple berry. Before all flavors are added, the smoothies go through a joint mixing process that costs a total of $43 per batch. One batch produces 21.75 cups of blueberry lemon smoothies, 29 cups of orange swirl, and 36.25 cups of triple berry. In addition, Gordon has studiously noted that the mixing process necessary for triple berry and blueberry lemon takes twice as long as it does for the orange swirl smoothies. Allocate based on weighted average. So we take the cups per batch times our weighted average to come up with weighted cups. Again, if blueberry lemon is 43.5 of the total 145, we'll take 30% of those costs to allocate for blueberry lemon. We'll take for the orange swirl 20%, and for the triple berry, we'll take 50%. Davis Pharmaceuticals subtracts the $320 of mercury revenues from the joint production overhead costs for each batch to arrive at the net overhead to be allocated to its 3 main product lines. So when dealing with byproducts, because of their low value, it's not really worth separating all these product costs. So the revenues just get offset. They offset the costs of the joint production process. Here, when we allocate support department costs and joint costs, ultimately, however we choose to allocate them, are going to have consequences to the product costing. So say a production manager bonuses may be tied to decreasing product costs, and the production manager who keeps costs down are more likely to keep their jobs and be promoted. So to look at this, let's consider the following performance reports of 3 managers who oversee 3 separate chemical lines. One oversees Olifax, Dryson, and Gestel. So this analysis here suggests that more information is needed to really evaluate these 3 general managers. Preliminary analysis of this indicates that Tanisha's the top performer because she's closest to target. Then it would be Jen and then Jamal, but it's likely that this ordering may switch to Jen, Jamal, and Tanisha after further analysis. Now we're going to look at another method, which is the most complex, but will result in the best outcomes. It's called the reciprocal services method. This takes all those support departments and considers inner support department services. The reciprocal method is more difficult, but let's take Decker tables and show how they use the reciprocal method to allocate these support department costs. Steps 1 through 3 of the reciprocal method are the same as for the direct and sequential methods. Support departments never allocate their own costs to themselves, as to do so would defeat the purpose of support department cost allocation, since they ultimately have to go to a production department. Accordingly, the two shaded cells in the table are not needed, as these drivers represent services the support department used within their department. The proportional usages of janitorial services are the same as those indicated with the sequential method. But the proportional usages of cafeteria services are different because the costs of cafeteria services rendered to the janitorial department are also allocated under the reciprocal method. So, as you see here, the support department costs are allocated simultaneously among the departments using an algebraic equation with variables for the unknown quantities. Costs are allocated from janitorial to cafeteria, cutting, and assembly by multiplying the total janitorial costs by the proportional usage of the other departments. The total janitorial costs, however, include an unknown amount for costs related to its employees' use of the cafeteria, which is expressed by the unknown variable J. Costs are allocated from cafeteria to janitorial, cutting, and assembly by multiplying the total cafeteria costs by the proportional usage of the other departments. The total cafeteria cost is going to include that unknown J for costs related to the cafeteria department's use of the janitorial department services. That's going to be expressed as C, the unknown variable. The total costs of the janitorial department will include 20% of the cafeteria department's cost, which is the percent usage of the cafeteria by the janitorial department based on employees. Since C represents the total cafeteria department's costs, the total janitorial costs can be expressed by janitorial cost is $310,000 plus 20% of the cafeteria. The total cost of the cafeteria department will include 50% of the janitorial department's cost, which is the percentage usage of janitorial services by the cafeteria department. Since C represents the total cafeteria department costs, the cafeteria cost can be expressed as C equals $169,000 plus 50% of J. The preceding yields two equations, two unknowns. Equation 1 is about the janitorial department, 310 plus 20% of C. The equation 2 is the cafeteria is 169,000 plus 50% of J. We can rewrite this by C equals 169,000 plus 50% of times J, or C minus 169,000 equals 50% of J, or C minus 169,000 divide both sides by the 50% equals J. We're going back to some algebra, aren't we? The J in equation 1 can then be replaced by C minus 169,000 divided by 0.50 equals the 310 plus 20% of C. Now we just have to solve for C because we've replaced the J. So C minus the 169,000, if we multiply both sides by the 0.5, is going to equal 50.5 times 310,000 plus 0.5 times 0.2 times C, or C equals 169,000 plus 155,000, which is the 0.5 times 310,000, plus 0.1 times C. C minus 0.1 times C equals our 169 plus 155. Or we can say 90% of C is 324. We divide both sides by 0.90 to come up with C equals 360,000. Lots of work. Then we can take, since janitorial now we know is janitorial costs are 382,000. We can then take the cafeteria at 50% of usage, allocate that cost. Cutting takes 10%, assembly takes 40%. Since the total cafeteria department cost is 360,000, which has now been determined, we can allocate to the janitorial cutting and assembly by multiplying it by the users. Here, as you see in this slide, after the support department costs have been allocated, the support departments have no costs remaining. Since all costs have been allocated to the production departments, management can apply the production department cost to products. Because the reciprocal services method accounts for all inter-support department services, the allocations of the 1,758,200 for the cutting department and for the 904,800 for the assembly department yield more accurate support department allocations than if we used either the direct method or the sequential method. Here's another example of this reciprocal services method. The reciprocal services method, of course, is much more complex. Mazer Productions, a film production company, allocates the cost of two support activities, security and meals, to the production activities of filming and makeup. Security costs are allocated based on asset value, while meal costs are allocated based on headcount. Thus, costs distributed to each department and the activity driver levels for each support department are shown. So we've got the asset values for security, meals, filming, and makeup, the headcount, and the department costs. The proportional usage of each support department's cost driver by the other departments are going to be allocated as such. So security department's usage for meals, 10%, filming, 85%, makeup, 5%. And then you also see the asset value, because the security department, I believe, is based on the asset value, is how they like to allocate that. Meal department usage, we've got the headcount. So the security department is basing it on asset value. The meal department is being based on headcount. Since department costs are allocated simultaneously among the departments, X is going to be the cost allocated to security, Y is the cost allocated to meals. Total cost of the security department will include 20% of the meal costs. So security department equals their cost, $250,000 times plus 20% of Y. Total cost of the meal department is going to include 10% of security costs. So the meals are going to be $465,000 times 10% of X. So we know that X is $250,000 of 20% of Y. Y is $465,000 plus 10% of X. So if we solve for Y, we would say $465,000 plus 10% of X, or Y minus the $465,000 equals 10% of X. If we divide both sides by 10%, Y minus 465,000 divided by 0.1 or 10% equals X. Now we replace X with the equation 1. Y minus 465,000 divided by 10%, since this value equals X, Y minus the 465,000 divided by 10% equals 250,000 plus 20% times Y, 20% of Y. Therefore, Y minus 465,000, if we multiply both sides by 10%, we have 10% of 250,000 plus 10% of 20% of Y. Ultimately, as you play this out and you divide both sides by 0.98, Y equals 500,000. So, since we know that Y equals 500,000, we can now take the to figure out what the security department costs are. The security department is going to be the 250 plus 20% of Y. 20% of Y is 100,000 because we know Y is 500,000. So the security department now is 350,000. So we can allocate the security department to meals, filming, and makeup. The total meals department of 500,000 can be allocated to the various departments, the security, filming, and makeup. So the support department cost allocations using the reciprocal service methods is going to be shown right here. After support department costs have been allocated, the support departments have no costs remaining. Since all costs have been allocated to the production departments, management now can apply the production department costs straight to the products. Which support department allocation method takes into consideration all inner support departmental services? The reciprocal services method. So guys, hang in there. We have 2 more exercises to go through. Jolly Roger Raffa produces tennis rackets. The tennis rackets are produced in the cutting and assembly department. The production of the tennis rackets is supported by the janitorial and cafeteria departments. Janitorial department costs are allocated to the production department based on square feet. The cafeteria department costs are allocated based on number of employees. Department information is shown here. I think I left out here. This should be assembly right here. Cutting, this is assembly. Using the reciprocal methods, services method, find the total cost to be allocated from the cafeteria department to the 3 other departments, and the total cost to be allocated from the janitorial department to the 3 other departments. So we need to start with the total cost to be allocated from the janitorial department is going to be X. Y is going to be the cafeteria department. We know the total cost of the janitorial department include 10% of the cafeteria department's costs. The total cost of the cafeteria department is going to include the square feet of the cafeteria, the percentage of square feet of the cafeteria for the full, and the janitorial department's cost. So the janitorial, the cafeteria is 20% of the square footage. So 20% of the janitorial cost is going to go to the cafeteria. So we know that for the janitorial department, we've got $3,030 in costs, plus we're going to need to allocate 10% to the cafeteria department. The cafeteria department has $4,000 in costs that's going to have to allocate, in addition, 20% of the janitorial costs. So Y is the 4,000 plus 20% of X. We move the 4,000 over to the other side of the equation. Y minus 4,000 is 20% of X. Or Y minus 4,000 divided by 0.2 equals X. If we know the equation, if we know that X is y minus 4,000 divided by 0.2. Okay, so we know that. We can fill that in for x because that's what the equation for x is going to be. Therefore, we can figure out that since we know what x is, we now can solve for y. So y minus 4,000 divided by 2 equals the 3,030 plus 10% of y. Y minus 4,000, we multiply both sides by 0.2, will give us 20% of 3,030 plus 20% times 10% of y. We subtract the 0.98 or divide both sides by 0.98 to come up with that y is 4,700. Now, since we know y, we can plug it into the equation to find out what x is. So since we know y, what y is, x now is going to be 3,500. Here, Temple Lights produces Hanukkah menorahs in its cutting and molding departments. The maintenance and security departments support the production of the menorahs. Costs from the maintenance department are allocated based on machine hours. Cost from the security department is based on asset value. And here's the information. So again, we need to calculate for the maintenance department and for the security department. We know the maintenance department is going to utilize some of the security department, and the security department's going to utilize some of the maintenance department. So you come up with your two equations, and then once you have those equations, you can substitute the equation for M into that S equation and figure out if S is 20,000, you can then plug it in for the M equation where M is the 40,000. And ultimately then allocate the various costs to the different departments. So guys, there you have it. Oh, did I do something wrong here? Ultimately, this shows you the breakdown of the costs being allocated and then your total costs for the two production departments. Well, I hope this has been helpful for you guys. I'll see you again, Chapter 6.